All right, here we go. So if z is equal to -4 plus 5i and w is equal to -1 minus 2i, when I do z plus w, I'm literally just going to do -4 plus 5i plus -1 minus 2i. And when I do that, how do I add complex numbers? Just combine like terms. Very good. So I'll add up my reals. So what's -4 plus -1? Very good. And then what's 5i plus -2i? Perfect. Make sure you put a plus sign in between. And then a couple questions I got yesterday between both classes is order does matter. It has to be the real part plus or minus the imaginary part. All right, even though 3i minus 5 looks the same, it has to be in the a plus bi. Any questions on adding for anyone that might have been absent or anything? But I think everyone was here. Z minus W, same concept. You have -4 plus 5i minus -1 minus 2i. The only difference is when I do this, make sure the negative gets applied to both situations. So when I go to combine these, what is -4 minus -1? Ends up being -4 plus 1, which is what? -3. Very good. So you can go ahead and distribute, make it a positive, and then add it that way, or just read it as minus a negative. And then what is 5i minus -2i? What's the minus negative going to do? Plus, so what's 5i plus 2i? Ends up being 7i. Questions? All right. Then we get to this one. This will just be -4 plus 5i plus 2 times, where's my W? -1 minus 2i. I'll have to move this part over. What do I got to do first? All right, so when I distribute, I'll get -4 plus 5i. What's 2 times -1? What's 2 times -2? Very good. And now I'm able to do what? Very good. So then I get -4 minus 2, which is, and 5i minus 4i plus I. Very good. All right. By chance, did anyone actually work out z minus z? Yes. What did you get as a conclusion? Yeah. Yes, you should have gotten a result here of 0 because if I'm subtracting the exact same vector, it would zero out. If you ended up doing it, you'd end up with -4 plus 4, 5 minus 5, and it all ends up being 0. I would accept this as an answer. Do note, though, if it's specific to wanting a complex number, to write it as 0 plus 0i, but I would accept just 0. It just depends on what the question's stating. It could, and you can still work it out if you still don't believe me. But any questions there? And then the last question was, how do you add, subtract complex numbers? Adding is very good. Any questions on how to add or subtract? Awesome. All right. So when we get into today's stuff, which is vectors, I want to go over a couple of vocabulary words that you might have seen in physics, or if you're currently in physics, you might be seeing now. So let me open a new page. All right, so we started off with this concept of a complex. Oh, well, let's title this. These are notes. Yes, we're back in our journals right now. So this is lesson 6, complex numbers. As vectors. So we started off with this concept that a complex number I don't have any more Kleenexes, but it's on my thing to order. And we know a complex number now is written as a plus bi, correct? We agree? How did I write this as a coordinate? How would I write this as a coordinate? Very good. So this would just be the real part, comma, the imaginary part. All right. We'll go with this. So what you're going to now see is what we like to call vectors. Vectors tell us direction and distance. And for our vectors, we'll specifically kind of be looking from the origin. Can anyone tell me what the origin is as a coordinate? Very good. All right. So vectors tell us direction and distance from the origin. So this tells us we're going, well, not in more of an application purposes, you know, northeast, northwest, southeast, southwest, straight, due north, due south, due east, due west, stuff like that you might hear on a boat or an airplane. We're just going to look at it. It's in the first quadrant going in this direction, or it's in the second quadrant going in this direction, or it's, you know, in the third or fourth quadrant, and then what the distance is. But any questions up to this point? All right, some notation for vectors. You'll see it in all kinds of different ways. You'll start seeing vectors written as like V equals, or you might see W equals, or some type of letter to represent it. And I can't really do this on this one, but they're typically bolded. So when you see these letters and they're bolded in your print, that's representing some type of vector, right? So a bolded letter represents a vector name. So it's either V, W, Q, R, whatever, but it's going to be bolded. Not italicized, but bolded. Then you can get it can be noted in 3 different ways. First way, I can use these guys, which look like inequality symbols, but that's noted as a vector symbol. So what it tells the reader is if I use parentheses, this right here just represents a point. But this right here represent what we like to call a ray. From geometry, can you tell me what a ray means? Yes. Yes, it has one endpoint. Perfect. So an example of a ray would be like this, where it has one infinitely going direction, but has one endpoint. Right? So that is what a ray has: an endpoint and infinitely goes in one direction. All right. Any questions so far? You're not going to see these 2 ways typically from me, but it could be something on an SAT or an ACT type question. You can see it also noted as, you can see it as parentheses, but then written vertically. Yeah, so this is a different notation I've seen on SAT question. That would be considered a vector. So instead of it being written as horizontal for a coordinate, they'll do it vertically with parentheses to also represent a vector. A different way you might also see it is with square brackets as well. So all 3 of these notations would be notations for vectors. Any questions on notation? This is the technical side. The math is still pretty easy. We good with that? All means the same. I'm going to probably stay around bolded letters and this notation, but I don't want you to be confused if you ever saw like this on another textbook or a test you might be applying for, something like that, and you see those notations. We all good with this? All right, let's get into the math. The reason we come to this class. All right, so let's look at an example. I guess I'll just need to stay over here. All right, so if I look at this example, z equals, this is not bolded, this is just a regular vector. And I say -3 plus 4i. It's not a vector. No, sorry, not a vector. This is just a regular complex number. All right, and let's say this complex number here is -3 plus 4i. How would I write this as a coordinate then? Okay. So then let's say we needed to graph that. What is the x-axis considered? It's this, yes, but what is it considered? What's the x-axis considered? I know it's the horizontal line, huh? Real, very good. And the y-axis is considered the what? All right, so that has not changed when we talk about vectors. And then when we graph this, how would you graph -3, 4? Backside, okay. Left from the origin. Oh, too many. Up 4, very good. So I'm going to go from the origin, I'll go left 3 and then up 4, very good. And then this is where my coordinate would be, and I'd be done, yes? I would label it and I would say this is my z. I've accomplished what you wanted me to do. If I want to do this as a vector, so as a vector, pretty much. So a vector, we would rewrite this using notation. And now, oh, I might have a better shot this way. A vector would be from the origin, right there. You've now graphed a vector. Is that it? That's it. All right. Now, there are some other vocab words that you might see as well that I want to make sure you understand it when some directions is trying to tell you to do something. And it's tail and tip. This right here, this will represent the tail. It's the tail end of the ray. And then this right here will represent the tip. It's the tip of the ray. So if you see notation like that, that's what tail and tip means. Tail is basically the beginning of it. The tip would be the end of it. Questions on that? Yeah. Well, here's the issue. There are questions I've seen on the SAT where it's like, if we connect the tip to the tail of this other vector, where would it land? And if you don't know what tail and tip means, you're like, you mean you just do this? But it'd be like, all right, take this and you're going to be moving things. So that is something we're going to be getting to that you might see as well. Questions on that notation? Questions on graphing a vector? All right. Now, I told you that vector was two things. I told you it was direction. We have our direction. But it was also what? Not displacement, distance. All right. To calculate distance, see if I can do a different color here. I would need to figure out what this guy is. Right? What is your thought process on trying to produce this distance? What do you think? From point to point, from tail to tip. Right. Oh, that's like slope. How would you find distance? How would I find the length of this diagonal? Okay, so I have the length of the real axis. I see that that's 3. There it is, Pythagorean theorem. So this right here, this distance would be 3, and this distance would be what? 4, right? So now you're producing what we used to call Pythagorean theorem. I say used to call it, still called that. But it is a squared plus b squared equals c squared. Now, I'm not going to keep it in that form. because it's always going to be this same process. So I'm going to write a formula out so that you understand that this is the formula you're going to plug in every time. I'm trying to calculate this C, which is the distance. Another, I guess, word you might call this. So distance has another word. Does anyone know it? Magnitude. You see this more in physics, but it has magnitude. What's that Despicable Me movie where it's like vector, he's distance and magnitude or direction or whatever it is that he said that he's referring to an actual vector, like Victor or whatever is, well, I don't know his name. Anyway, so to calculate this to have one clean formula, it's going to be the square root sorry, it's going to be I had a brain fart. It's going to in this case, it's just simply x squared plus y squared, whatever your coordinates are. But it does get a little different when there's more to it. Yeah, I'll change it to A and B. Does that make more sense? There you go. Right. Right now, it stays this way because we're at the origin. It might get a little different when we get past the origin, but we'll cross that bridge when we get to that point. But for now, it's simply just this. So if I want to know what the distance of this is, I'm just going to figure out what 4 squared plus, now this was a -3 originally. Let me go back to that part. You can put it in parentheses like this. But what's one thing we've learned about squaring negative numbers? What should the result always be? It's always positive. So if you don't want to mess up with your negatives and stuff like that with the calculator, just put the positive version of it and just stick with just 3. Right? It's just going to be positive. In this situation, and when you're doing this math. I still got to square it before you can't, the square root and the square don't cancel because of the plus sign. So if you do the math inside, what's 3 squared? 9. And what's 4 squared? 16. And then what's 9 plus 16? And what's the square root of 25? There's your distance. All right. Now, I will say 90% of the time, it won't come out even. You'll have to simplify the radical. So we'll see some situations like that as well today. All right. Any questions on how to find direction, which is the graph, or the distance, which is the formula? Pretty straightforward. It's a little geometry, but it's still there. All right. So let's look at some more examples then to make sure we got this down. Let's say I wanted to find the vector length of these guys. Let's look at it as Z2 equal to 2 minus 7i. And I also want you to look at Z3. Well, we just pretty much made that equation. Z1 was the first example that we just did. So look at, just do that one. Graphing paper definitely helps if you want to make them look clean. So, and I have graphing paper over there. But that will be completely up to you. Never give the result as a decimal. Make sure you keep it as a radical. So make sure you keep it as a radical, a simplified radical, but never give it as a decimal. Simple, like a little tree thing. If it can be simplified. Like technically 25 was 5 and 5, so it came out as one single 5 and there's no leftovers. Let me catch you where you're at. I know exactly where you're at, right? So if I wanted to find the magnitude of this, that would just be the square root of what? 2 squared plus -7 squared, or simply just 7 squared, however you want to look at it. 2 squared is -7 squared is, and then 4 plus 49 is 53. Is 53 a prime number? The red one. Right directly behind you. There you go. It is. So therefore, this will be your answer. Had it been able to break down, let's say hypothetically, it was like 54, then I would want to see what this can break down to, like 227. 2, not 2. Okay. Correct. And this would be like 3 and 9. And this would be 3 and 3. So then I could carry these out. So this would then be 3 on the outside. I got a 2 and 3 left over. So I have a 6 inside. All right. But this is not part of this example, but that would be like if I would have had square root of 54. Yes, you have stuff like that. All right. Questions on finding magnitude or distance or length, how you want to call it. All right, let's continue this discussion more with the graphing kind of concepts. All right, so let's say we have a new z that's equal to -4 plus 5i. We have a w equal to -1 minus 2i. And I want to start off by finding z plus w. All right, go ahead and find z plus w for me. Yes. Wait, we already did this? Oh, so it's a continuation of the warm-up? Oh, nice. What was the answer? I thought those numbers looked familiar when I was writing them. All right. Okay. So we already had it. Perfect. All right. So there's our stuff. We have z, w, and z plus w. We're going to graph all 3 of these as vectors. Okay. So here's my, I don't know what's going to be better. Here's my graph. What would this be as a vector? And then what notation will I use? Inequalities. Perfect. All right. So when I graph -4, 5, how do I do this? Very good. Yep. And then yes, and then we're going to draw our arrow. Cannot do that in this direction. A little arrow. Perfect. All right. Let's do W. I'm going to do a different color so we can see what's happening. How would you write W as a vector? -1. -2. And what goes around it? Inequality symbols. All right. How would I actually graph it? 2 down. Very good. Any questions on this? So putting multiple vectors on a graph? Not too bad. All right. If you are asked to then do Z plus W, the goal is to find out where that's going to go without doing the math. But you have the math as a backup, which when I was in your shoes, I did that first to make sure I fell in the right spot. But I need to figure out where this is going to go if I add the Z to the W. And I can try my best to physically do this. Maybe I can do it with this icon. You're literally going to take what this vector is, and you're going to take its tail and connect it to its tip. All right. Which then tells me that my Z plus W should land me right here. All right. So the new vector should be right there. And you're right. That looks like that's -5. Roughly 3. All right, but that would be -5, roughly 3. All right. And so then that's how you could do it vector-wise. Now, you cannot pick up your drawing off of your picture, right? Like you can't do what I just did. That's kind of hard. So let's do this as if I couldn't do that. I just wanted you to physically see it. Okay. So what I can do is what I'm going to do is I'm going to start at the tip and I'm going to pretend that is my origin. And now I'm going to regraph W. So from the tip, what would I do? Okay. Perfect. Oh, man. Which puts me about right. Right there. Which again, I can see that that's going to be -5. And then that's (3), right? As the point, and then as a vector, all I would have to do is then connect the origin to its spot. Questions on how to show it graphically? Actually, you will be asked to have to do that. A lot of times they'll just give you a graph and then tell you what would it be if I added these two up or even subtract it even. Okay, so any questions there? All righty. Let's keep this same one. I'm going to open up a new graph. You can put it on the same one if you'd like, but it might look cleaner on the other side. This yellow one here, that represents Z plus W. What if I want it Z minus W? How do you go in the opposite direction? All right. So what was the numbers? There we go. So I need to put these back in for me. So I'm going to go with the blue here. And that was originally 1, 2, 3, 4, and then 1, 2, 3, 4, 5. This was my vector Z. And then I had -1, 2. So that put me a different shade. Put me right there. -1, 2. So that was my W. But just like where's my like Jacob just said, if I'm going to subtract W, the same concept as what we did on the warm up, and we distribute that negative, that W now becomes what? Becomes +1. And then comma +2 because it ends up being a +2i. So now instead of graphing it from here to here, I'm going to graph it from here to here. So now I get 1, 2. I am now here. 1,7? No, that's a 2. No, I'm just kind of showing you what's happening here. So this was the positive W. This is now the negative W. And if I want to know what Z minus W was, again, if I was able to just do this to my paper, I would just connect it right there, and then we know where that's going to land, right? Right? Because we did that earlier. So instead, because we can't move our objects, let's actually change it. So again, what we're going to do is we're going to go to the tip of our Z, and then we're going to graph our W from there. So we'll go right 1 and then up 2. And then there is my vector W as well to represent my Z minus W. Now, what is that coordinate there? Well, -3, 7. Is that what we got on the opening exercise? It is. Questions on how vectors work? All right, so you will be asked to do this algebraically and graphically. I know y'all got the algebra down. That was pretty easy the last couple of days, but do you have the graphing down? Yeah. Or does it at least look like you could have it down with some practice? All righty. So with that being said, let's practice. I want you to go to the exercises, and I want you to do 1 through 6, and that will conclude today.